Now, we're interested in statistics because it's supposed to help us unfold what's really going on in the plant or in the laboratory or in the pilot plant. And this is intimately involved with the scientific method. So what do you say we have a quick look, speaking in broad terms, of what the scientific method is all about? The scientific method invariably begins with some question that's raised and searching for an answer. For example, suppose you were a chemist and you were asked to produce a certain chemical, let's say chemical gamma. You know, you'd think about it a while, then you'd say, I think if I mixed alpha and beta together in certain concentrations, I ought to get some gamma. And so actually you start out with an idea or a conjecture. And then you begin to design the experiment. You say, well, what concentrations of alpha and beta shall I use? And I wonder what temperature environment I should put in, and shall I stir it or not? And what kind of a clave shall I use? And so forth. You'd actually think in terms of designing an experiment, trying to anticipate the environments that you want to organize for the collection of the meaningful data. And then, of course, you have to run the blooming experiment. And that's a large problem in itself, actually conducting the experiment. And after the experiment is completed, you take the results of the experiment and submit it to analysis. Now, what's the purpose of the analysis of the data coming out of the experiment? You can see this chemist. He's produced some gamma, to be sure, as a result of his initial experimental design. But upon seeing the amount of gamma and upon experiencing the experimental environment, he has new ideas about how he might improve his performance and so on. And so the analysis invariably leads to new conjectures, and we start around again, designing another series of experiments, running the experiments, and so on. And in this fashion, we acquire that amount of knowledge which is necessary to answer the question that's raised. Of course, the amount of knowledge is different in a research laboratory than it is in a pilot plant, than it is on a production floor. But this is the general technique which is evoked. And of course, the experimenter, the engineer, is predominant because he has the ideas. He chooses the variables that enter the experimental design. It's his ability to do titrations and perhaps do a little midnight requisitioning to get equipment or to badger money out of his boss to run the experiments and so forth. He enters here, and of course, in the analysis of the data. And one strange thing you want to be aware of here is that different experimenters analyzing the same data are going to come up with different ideas. But here is, roughly speaking, the scientific method. And where does statistical techniques come in? In two places. The purpose of statistics is to unfold the information in the data, to help in the analysis of the results of the experiment. And the purpose of the analysis, of course, is to lead to new ideas and new conjectures. And so our use of statistics is to stimulate this particular mental jump, which is vital to the scientific method. And of course, our ability to resourcefully analyze the data depends in large part on how the blooming experimental design was put together in the first place. And there are various methods of organizing the way in which the experiment is designed, which will greatly contribute to our ability to do a resourceful analysis of the data.